Below, we explore the history of the telescope and its discoveries and present Hubble facts and the best images from the extraordinary observatory in our orbit. Since its launch in 1990, the Hubble Space Telescope has produced the most amazing and inspiring images for both scientists and the general public. The dozens of terabytes of data collected are more than just beautiful pictures. They offer a glimpse of the universe from objects as close as the Moon to the most distant galaxies, with incredible photos of supernova and nebulae in between. Prepare for many more amazing videos in the future by subscribing to Simply Space. When Galileo first aimed a telescope at the sky in 1610, he had problems viewing Saturn's rings, which are now visible even with very basic telescopes. This was before the introduction of Hubble. The Earth's atmosphere continued to block much of the light for observers on the ground, despite advances in optics eventually improving scientists' views of planets, stars, and distant galaxies. It's interesting to note that larger telescopes are still positioned atop mountains because the thinner atmosphere there allows for clearer images at higher altitudes. It took a few more decades for the idea to garner sufficient support, and the National Academy of Science formed a committee of scientists to assess the feasibility of a large space telescope. Astronomer Lyman Spitzer first proposed sending a Vanza telescope into space in 1946, shortly after World War II, to overcome the limitations of ground-based observatories. The committee released a report in the National Academy of Science, submitted its proposal to NASA, the only organization capable of bringing the big space telescope to fruition. In 1969, after outlining the scientific advantages of the project and arguing for its development, George Low, the agency's deputy administrator at the time, approved the creation of the Large Space Telescope Science Steering Group in 1971, after NASA had previously explored the idea of a space telescope but was unsure of its size and where to begin. NASA then started pleading with Congress for funding for the project. In 1975, the House Appropriations Subcommittee first refused funding for the costly project, making it difficult to market. After then, NASA increased their lobbying efforts and gained the support of the European Space Agency, which helped to cover the costs. In 1977, Congress ultimately approved funding for NASA's portion of the Big Space Telescope. Development started fairly immediately, and NASA had originally intended to launch the telescope in 1983. However, a number of production setbacks caused the launch date to be rescheduled until 1986. In the meantime, the Large Space Telescope was renamed Hubble in honor of Edwin Hubble, an American astronomer who, among other things, discovered that the universe extended beyond the Milky Way's boundaries. The launch of the Hubble telescope was postponed once more after the Space Shuttle Challenger exploded on January 28, 1986, 1 minute after takeoff, killing all 7 astronauts on board. It took 2 years for shuttle flights to resume before NASA could start preparing for the Hubble launch again. On April 24, 1990, the world's first space telescope finally launched aboard the Space Shuttle Discovery. The construction of the Hubble telescope cost $1.55 billion, but there were both unforeseen and anticipated expenses that followed. One of the main instruments was the Wide-Field Planetary Camera, the High-Speed Photometer, the Faint Object Camera, the Faint Object Spectrograph, and the GUDAR, High-Resolution Spectrograph GIRS. From the start, Hubble experienced equipment issues, and the telescope's photos were so fuzzy that they were nearly useless. A manufacturing fault resulted in a spherical aberration in Hubble's primary mirror. The flaw was so small, just 1/5 the thickness of a sheet of paper, but it was significant enough to interfere with photo capture. NASA finally launched a repair mission on December 2, 1993, after 3 years of preparation. The Space Shuttle Endeavour carried a crew of 7 people on board to repair Hubble during a 5-day spacewalk. 2 new cameras, including the Wide Field Planetary Camera 2, WFPCC-2, which later took many of Hubble's most well-known pictures, were installed and tested during the repair. When Hubble's first new images arrived on Earth in December 1993, they were nothing short of breathtaking discoveries. Because light takes time to reach long distances, Hubble's unique perspective and sophisticated optics allow it to look farther into the distance than earlier ground-based telescopes could. Due to its reach, the Hubble telescope operates similarly to a time machine. When we look at the Andromeda Galaxy, which is 2.5 million light-years away from Earth, we see it as it was 2.5 million years ago, because the light from distant objects only shows what the object looked like when it was left, not how it looks now. For instance, in 1995, astronomers used the Hubble telescope to capture an image of over 3,000 galaxies that were too far away for other telescopes to detect. This discovery was later dubbed the Hubble Deep Field, and some of the galaxies were so young that they had not yet started to form stars. More deep field observations were made in the same area each time looking deeper into space. These were called Hubble Ultra Deep Field, published in 2004, and Hubble Extreme Deep Field, published in 2012, in addition to looking at the early universe. Hubble also helped astronomers measure how much time had passed since the Big Bang by measuring a special kind of pulsating star known as a Cepheid binary. They were able to narrow the age of the universe from 10 to 20 billion years before the IST to 7 billion years. Hubble also studies individual stars at various stages of their evolution, starting with the dust clouds from which young stars form and progressing to the remnants of those that have long since exploded. It was even able to peer outside our galaxy, the Milky Way, and into its neighboring galaxies, the Magellanic Clouds and the Andromeda Galaxy, more difficult to see than stars or planets orbiting other suns. But in 2008, Hubble captured images of the planet Fomalhaut b, the first time an extrasolar planet was imaged directly in visible light. Most planets, however, are more difficult to photograph. Much of the telescope's work with other planets is done by detecting their atmospheres as they pass in front of their suns. While Hubble spends most of its time looking into space, it occasionally stops to take pictures of the planets orbiting our sun. High-resolution images of Jupiter, Saturn, and even Pluto can offer insights that are only surpassed by planetary probes orbiting the planets. This is because the atmosphere filters the light from the stars, and Hubble records the changes. When comet Shoemaker-Levy collided with Jupiter in 1994, Hubble captured the deadly impact on camera, enabling scientists on Earth to track changes in the planet's atmospheres and surfaces. Hubble observed what appeared to be water plumes coming from Jupiter's moon Europa, and the aftermath provided valuable information on the gas giant's atmosphere. After making its first observation in March 2014, the telescope observed a similar object in February 2016, with Hubble in orbit for over 20 years. Astronomers now have a deeper knowledge of the planets, galaxy, and universe as a whole. Among Hubble's most remarkable findings and investigations include the development of a three-dimensional map of the enigmatic dark matter, the identification of the moons Nix and Hydra, which aid in calculating the universe's rate of expansion, and the realization that almost all of the large galaxies are anchored by black holes. Aiding in the determination of the universe's age, the Hubble has undergone multiple servicing missions. Servicing the first ST-61 mission in December 1993, the wide-field planetary camera was swapped out for a wide-field and planetary camera with an internal optical correction system after a corrective optics kit was added. Computers were updated. Additionally, astronauts swap out solar arrays, computers, gyroscopes, magnetometers, and other devices. February 1997, surfacing mission 2ST-82, among other things. The astronauts replaced the gears and FOSS on mission. 3ST-S103 in December 1999 with the Space Telescope Imaging Spectrograph STIs, the Near-Infrared Camera, and the Multi-Object Spectrometer NIC-MOS. 3 weeks prior to the launch of 3A, 3 of the 6 gyroscopes or alignment devices on Hubble failed, causing the third servicing mission to be divided into 2 parts. The telescope could not be aimed in the proper direction for observations because a 4th gyroscope failed. Mission 4 SS-125 was originally planned for February 2005, but NASA canceled it after the Space Shuttle Columbia was damaged during launch and broke apart during re-entry in 2003, killing 7 astronauts. Among other things, 3A replaced all gyroscopes, a fine control sensor, and the computer. Because Hubble is in a different orbit than the International Space Station, astronauts would not have a safe haven to retreat to in the event of a shuttle damage during launch. Nevertheless, the Hubble mission was resumed and rescheduled for 2008 following a public, scientific, and congressional outcry. Mission 4 astronauts fixed or replaced multiple systems and installed 2 new instruments after one of Hubble's data processing units broke, delaying the mission until 2009 to find a replacement. The Cosmic Origin Spectrograph and the Wide Field. Camera 3, please share your ideas in the comments section below about your impressions of Hubble's breathtaking space photos.